Alright, hello everyone. So today I'm just throwing together this brief video because I saw there was an Onshape forum post asking about asking for some more information on queries and IDs and some of the finer points like tracking queries and some of those other more advanced things, set external disambiguation for each entity, things like that. So I figured I would just throw together this brief demo video. Talk through some of the things I know. So I guess there's a little bit of background for me. I actually got into programming via FeatureScript. It was the first programming language I ever learned. I do have a degree in computer science from the University of Texas at Dallas. So FeatureScript was kind of the catalyst that got me into computer programming. And so, it's the first language I ever knew, which was quite the experience. I am now a professional software developer. Although I don't use Onshape normally, but I still mentor a robotics team, and so I still write FeatureScript and develop Onshape apps in my free time. And I've used Onshape professionally in the past while I was in college, and I've also written FeatureScript professionally in the past while I was in college. So I do have a fair amount of experience, and I kind of have a fair amount of computer science experience, and so I kind of bring that perspective as well. Yeah. So let's get into it. So first thing we'll talk about is queries, right? So I'll start with some basic background information, right? A query, as we all hopefully know, is just a set of instructions for how to find entities in a Part Studio context, right? And so the key thing here is it's a set of instructions, right? So often when we're modeling or creating features, we think of a query as representing a specific thing or a specific entity, right? So for example, in my belt feature script, right? After I've created like the physical belt, I might have a query for that belt that I'll call, const belt equals, the query for the belt that was just created. And that's a perfectly fine way of thinking about it, and that's very reasonable. But at the end of the day, right, a query is just, it's just a map saying like, hey, like you should look for something with this ID, and maybe like check that it's not, something with this other ID, right? And you're just like nesting your queries, and I want it to be within this specific point in the Part Studio, right? So it's, but that, but that's just a basic set of instructions. That doesn't actually mean anything until you also supply a context, right? And so a query for a belt, while we know like, hey, in our current Part Studio, because I just created that belt, we know this is going to actually evaluate to that belt, right? If you take that query for a belt and put it in a different Part Studio or in a different context, it's probably not going to find a belt. And so, and that's still perfectly valid. The query is just not going to resolve to anything because in a different context, there is no belt that query is going to be able to find, right? And so that's just something you should try to keep in mind. A query isn't actually in and of itself an entity or like representing something. It's just instructions to find it. So here's that information again, right? It's just instructions. It only makes sense when evaluated against the context, which is that parameter that evaluate query will take, right? And that thing you have to pass through all of your functions and things, right? When you're writing a feature script, it typically represents one or more entities in the graphics window, of course. And I guess the point, right? So one consequence of it just being instructions is constructing queries is very, very cheap, right? Because you're just, nesting together maps and arrays of like basic data. There's no actual like parsing the tree or like, going through your Part Studio and actually figuring it out. That doesn't happen until you actually pass it into a feature to use it, or you call evaluate query on it. Because, as you hopefully know, evaluate query takes a context. And it needs that context because that's what it's going to run that query against to find out what sub-entities we have at this moment in time, right? And another thing is you can only find things that actually exist because it is just querying for entities, right? So if there isn't something in the graphics window, then it's not going to be able to like create a query for that, right? So the classic example is you can't actually query for like, like the cylinder that's like a hole, right? Because a hole is just, it's an open void, it's an empty space. There's nothing to actually query for. Now you can of course query for the cylinder around that hole, right? But you're not going to be able to query for like that whole cylinder itself because the whole feature deletes it as a part of its as a part of its execution. Once it's finished, it deletes it. And so once it's gone, there's nothing to query for anymore. Yeah. Okay, so moving right along. So evaluate query, right? We talked about it a fair amount, right? This just converts a query into an array of individual queries, one for each individual entity, right? It requires a context because a query is otherwise just instructions, right? So just harping on that point, a query is just basic instructions. You need a context to give it meaning, right? And it's generally going to be one-to-one with selections inside your query parameter, right? So if so you have a query parameter where the user is making selections, evaluate query is going to give you an array of results, and each result in that array is going to match one-to-one with one of those user selections. And one other thing is, back in the olden days of FeatureScript, evaluate query, checking if the result of evaluate query was the empty array was the old way of checking whether a query was empty, right? And that makes sense if you think about it, because you would need the context to tell if a query actually resolves for something, because you have to actually go and check against whatever context part studio you're currently operating in. But nowadays there's is query empty, and that's very similar to evaluate query under the hood. It just fails fast if the query has multiple results, right? Because if you think about valid query, it's going to exhaustively search that entire query space to build that entire array. Obviously you don't need to do that if you just care whether or not it's empty, right? As soon as you find something, yeah, it's not empty, we can return true, right? And return false, I guess, and move right along. But that's why is query empty and evaluate query take context, right? Is because you do need that for queries. So basic high-level information. Hopefully most of that is familiar. And so some basic discussion for working with queries now, right? So naming, typically you're going to name a query for what it represents, right? There is also the Q something pattern. So in the standard library, and a lot of features, but not all of them, they'll take the pattern of any query that they have. They'll start with Q and then, the name of the query. Just that way it, is a little bit clearer what isn't a query. I personally don't do that. I think it's a little unnecessary. But that's certainly something you can do if you want to, have consistency and just make it a little easier to identify what's what inside your Part Studio or inside your Feature Studio. Other notes: the chaining operator works really well for applying filters, and queue subtraction with queries specifically. I think queries are one of the specific motivations for them creating that operation in the first place, right? Here's some basic examples, right? Most queries will take the query as the first argument, right? And then, the filter or whatever as the second argument. So like with subtraction, right? I always think, it always makes sense to me that whatever's on the left is what you have as the original query, and then Q subtraction, whatever is in that parentheses, is what you're going to be taking out of it, right? So you can kind of think of the Q subtraction as like a minus sign, right? So A minus B equals, whatever that is. Same with the Q intersection, right? Where the Q intersection kind of becomes a plus sign, so you're taking the left side and the right side and you're adding them together. Or I guess that's Q union. Q intersection is the, what's the same between them. And then of course with filters, right, you have whatever's on the left, you run it through the query in line like that, and so now you're going to have solid queries or whatever is in those parentheses. And then note about subqueries, right? So oftentimes we'll iterate over something, and we'll want to build a new query for our results, right? So for example, if you're iterating through a bunch of user selections, and for each user selection you're creating some geometry, right? And then you want to create a master query for your individual operations, right? You can often choose between creating an array and then building an array of queries, right? Or you can have a query that starts with Q nothing, right? And you can Q union on each result as you go through. Generally, we prefer building an array of subqueries and then calling Q union once on the result, rather than successfully Q unioning on results one by one onto a main query. Just because when you do that, right, it really expands the structure because it becomes deeply nested at that point, and we have a lot of nested Q union calls because you're just adding on one by one by one. Whereas if you Q union just once at the end with an array of subqueries, right, then it can kind of evaluate all of those in parallel almost. And so that's just generally better for performance. Yeah, so hopefully that makes sense, and you can visualize that. I know I'm not really like showing any concrete examples, but I like to think this is all like relatively standard stuff. Yeah, so we'll move on to IDs now, right? So IDs are kind of confusing because a lot of the time it's not really clear like why you need them or what they're for, right? And so it's just kind of something you have to do, and sometimes Onshape gets upset at you and yells at you for having your IDs out of order or incorrect, and you don't really know why you even like care or why you even need these in the first place. And so the biggest thing to understand with IDs is, well, first of all, internals, right? So an ID is just an array of strings, and so when you have a new feature, right? So let's open one real quick, I guess. This is just my library of custom features that I've made. So I'll just open a random one. Sure. So every feature, right, you're going to have a defined feature call. You're going to get a context, an ID, and a definition, right? And so the definition is obviously your parameters, right? Context, as we've been saying, is an internal, so you never really have to operate on it directly. But you can just think of it as the current part studio, like all of the geometry inside it, right? Which is why evaluate query and various features need it, because they're going to make changes to that context for you, or take a query and run it against that context to determine what's happening, right? Or if that query exists right now and what it evaluates to. But then you have the ID, right? And so this top level ID you can think of as your the ID of your feature, right? And so by default, it's always going to be an array of size 1, and that the contents of that array is going to be a string that's random, that's unique to your feature in your Part Studio, right? So that's what we mean by feature ID, is that top level ID, right? And it's a little confusing because generally as you're programming, you're not really thinking about whether you have a top level ID or a sub ID, especially if you're writing lots of functions. But that feature ID is what we're referring to in this specific context, right? So that's the root. So one of the consequences of the way IDs is defined, right? So it is just an array of strings, but Onshape imposes a requirement that it has to be hierarchical, right? So your feature ID is always going to be the root of your tree. So every ID in your feature is going to stem from that root feature ID that's passed in, right? And the way you extend that tree is you use the plus operator, which for IDs is overloaded to the append operator, right? So when you do plus and then a string, you're really just taking that ID array and you're appending your value on, right? And so the key to understand is this is forming a tree with the passed in feature ID as a root, right? And then every sub operation you do by chaining on additional pluses, right? You can query for directly, right? And the other note is it has to be contiguous, right? So if you program for any amount of time, you've probably seen the your feature IDs are not contiguous or not in a continuous order, right? And so what that means really is when Onshape thinks about your model history, right, it likes to think about it in terms of having a single set of basically, like if you think about the IDs as a tree, right, it wants to be able to traverse that tree in order from start to finish. So at the start, there's just the feature ID, there's nothing in your Part Studio, right? Then it has the first operation, which it adds something, and then the second operation adds onto that, and then the third operation adds onto that, and so on and so forth, right, all the way through. And so what happens is if this operation here were to point like over here, for example, so in that case you would have created an ID and then ID 7 and then added on ID 2, right, and then you create ID 5 and now you try to add on ID 6, right, while also having that ID 6 is like a sub ID of 7, right? So now when you go back in history, if you're trying to step back through history, you no longer have that rigorously defined order, because it's now ambiguous when you get to this node whether 5 came first or 7 came first. And so essentially you create like a form of time travel almost, where it's no longer clear what the specific timeline is, right? And so that has problems for Onshape, as they're trying to optimize performance and make sure things can be evaluated correctly and if they try to cache off part of the tree so they don't have to evaluate every time, then if you have that type of overlapping history, it becomes a problem, right? And so if you look at the standard documentation for it, right, they have some suggestions for how you can go ahead and define your IDs. So you can either rearrange your IDs when you're looping, or add it on, or unnest it. But you have to follow that history. And so that's the core reason why, is because you need your IDs to be in order. And so now you might be thinking, okay, well that's neat, but what's the practical advantage of that? And the reason why having the IDs defined in this way is because it allows queueCreatedBy, which takes an ID and returns what that ID has, what operations are associated with that ID, right? queueCreatedBy will traverse that tree automatically, right? So when you pass in an ID that's higher up in the tree, right, and if you've chained on additional operations underneath that ID, queueCreatedBy will automatically return the results of every operation that ID has created and that children of that ID have created, right? And so one way that's useful is if you think about your feature ID, your root ID, right? queueCreatedBy, called with your root ID, your feature ID, is always going to return everything your feature has done up to that point, right? And so a salient example of that is if we go look at some source code here. So there's this function, what is it called? Transform result if needed, or transform result if necessary. That's right. Right. And so if we go look at the implementation of that, so if we look at the implementation of transform result if necessary, right? So all this function does is it takes a context, an ID, and a transform, right? It checks if the transform is not the identity transform. And if it's not, then it will transform everything created by that ID, right? And this function is used in a lot of places inside the Onshape standard library. It's part of the pattern module. In order to make feature transforms work, basically, because it's not possible to query for something that doesn't exist, right? So if you think about like trying to feature pattern the whole feature, for example, right? You can't feature pattern the result after the whole feature has completely finished running, because the way the whole feature works is it has user selections. It creates whole tools, and then it cuts parts with those whole tools, right? And so the problem is, as a part of its execution, it deletes those whole tools after it's done booleaning, right? Which makes feature patterning very difficult. On the other hand, right, if you didn't have those whole tools, or if you didn't delete those whole tools, then feature pattern would be pretty easy, right? Because you could pattern those tools, right, and then you could boolean them all at once at the very end. And so the idea behind feature patterning is every feature can have an optional additional transform passed into it, right? And the idea is when your feature is executing, if you see you have that transform populated, right, instead of just like executing your normal feature, you should apply that transform to any tools you have in your feature, so that way you can move them to wherever the pattern feature says you should move them before continuing through and executing. And so apply transform or transform result if necessary is the latter half of that operation, right? So a lot of standard library features will use that feature. If you check the feature pattern documentation, I'll talk about it. But the underlying mechanism that they're taking advantage of is they're relying on the fact that you're passing in the feature ID, the root ID here, right? So when they call queueCreatedBy ID entity type.body, right, that is going to query for everything your feature has created at that point, right? And so if you created, some tools or some pulleys or whatever solid geometry your feature has created, right, it is going to return that, and it is going to transform it, and therefore you are able to, it is able to basically give you the feature pattern in a very concise package, right? So you shouldn't really have to think about it too much. So hopefully that's not, hopefully that, so that's kind of a high level example. It's a pretty abstract standard function. I guess to give something a little more concrete, right? So we'll go look at my robot pulley feature. So this just creates various pulleys, right? And so if you look at the standard library documentation for ID, right, they have this section here where they talk about subfeatures and, like nesting IDs. They kind of show a little bit using, I guess they don't really show queries using those sub IDs, right? Generally speaking, right, subnodes of the tree will fall under distinct operations, right? So for example, for the pulley feature, right, I have ID plus, I have my root feature ID, but then I have ID plus pulley for, everything that creates like the solid pulley here, right? I have a flange ID for, all of my flange creation stuff. I have ID plus mate connector for all of my mate connectors, and I have ID plus bore for my bore, right? ID plus text for my text, right? And then any of these features will have, any number of subfeatures underneath this top level ID, right? So add mate connectors will obviously have, one or more mate connectors underneath ID plus mate connector, right? And so on and so forth. But by defining it as, a subnode of my ID tree, that makes it very easy to query for all of those results directly, right? So for example, if I want my flanges, right, here it's back to ID because it's a parameter, and so like the argument kind of abstracts away the ID plus flange, right? But when I'm inside this feature now, right, like I can delete all the sketches created by this feature using ID, right? So that's ID plus flanges, right? But that's abstracted away from the rest of my features, right? So I know it's only going to delete these features, and I don't have to worry about going through and like selecting my individual sketch entities, or even my sketch itself, right? Because this is called in a loop, but this is, just called once, right? So it just, so by taking advantage of that hierarchy, and using the root of that hierarchy, we're able to immediately operate on everything inside that without having to worry about the niceties of what exactly that structure is. So hopefully that makes sense and isn't totally confusing. But yeah, so that's one of the key advantages of hierarchical IDs, and by being able to take advantage of that, you can operate very efficiently, right? And it's worth noting too, you already take advantage of that implicitly, right? So if you think about, a basic operation like, like skRectangle, for example, right? skRectangle internally creates, 4 sketch lines, some points, and, some constraints, right? And those are all going to be nested under whatever ID you pass into skRectangle, right? And so when you query for the results of skRectangle, because IDs are hierarchical, you'll also get, you'll always get like the points and the lines, and the constraints that skRectangle has created automatically, even if you aren't, so you don't have to like go in and individually query for like the top edge and the left edge and, the 4 points and things, if you want to operate on those guys. So you don't have to worry about that, right? And that also comes up for like sketches, for example, right? A sketch, all of the sketch entities you add will be nested underneath the sketch ID itself, right? And so if you want all the sketch entities created by a sketch, you can just query for, whatever ID you pass into that sketch, right? And you'll immediately get them all, and you don't have to worry about, each sketch entity you've added, right? So here, for example, I create a sketch, right? It's under flange ID plus sketch, right? Which is my sketch ID. I guess I don't use this variable because I'm silly. Right, so it's all under sketch ID, which is flange ID plus sketch, right? And so when I want to query for everything, I just queue created by sketch ID, and this will be all the faces created by my sketch, right? And so I don't have to worry about, trying to figure out where my individual faces actually are. And you can do the same for all the points or all the edges, right? You don't have to think about it. Okay, so hopefully that makes sense. So now moving on. So next we'll talk about unstable IDs, right? And so really the function to think about with unstable IDs is set external disambiguation, which is kind of that low-level function that operates, right? And so all set external disambiguation really does, right, is instead of using feature evaluation order to determine the stability of a given ID, right? So for example, right, by default in my pulley feature, right, because we take multiple user selections and we create multiple pulleys, one at each selection, right? So if the user selects, 0.1 and then 0.2, right, we'll create a pulley at 0.1 with, ID equals pulley 1, right, and then we'll create a pulley at pulley 2 with ID pulley 2, right? And so that's the default behavior, right, and that works pretty well, right up until someone deletes, until the user deselects pulley 1, right? So when they deselect 0.1, right, what's going to happen? Well, if you think about iterating through from a feature perspective, right, pulley 2 is now pulley 1, right? So pulley 1 is going to break because the point is gone, right? And so it doesn't exist anymore. So that makes sense. But then pulley 2, right, which is still selected, or actually, sorry, so pulley 1 is not going to break, right? Because we had 0.1 and 0.2, which created pulley 1 and pulley 2, right? We've deselected 0.1, right? And so now we just have 0.2, right? But because there's no more 0.1, right, 0.2 is now 0.1, and 0.2 is gone, right? And so our pulleys are actually going to follow that behavior, and they're going to shift accordingly, right? So it's actually going to be the exact same thing, right? So pulley 1 is actually going to move to 0.2, right? And 0.2 is going to break. So like if pulley 2 is in assembly, it's going to turn red and be broken, right? If pulley 1 was in assembly, it's actually going to be okay, even though we've deselected the point that was being used to generate it, right? And is now going to move to 0.2. And so if you had, something that was mated onto that, like that's going to jump, right? Because that pulley has moved, and the pulley you would expect to be okay is just going to break, right? And so that is obviously hugely disastrous, not at all what you want, right? Totally messed up, right? And so the solution is, instead of iterating over and saying, our first selection is going to be pulley 1, our second selection is going to be pulley 2, right? You say, whatever query the user has selected, whatever point, right, that's what we're going to associate with pulley 1, right? Whatever point the user has selected, whatever query that is, that's what we're going to associate with pulley 2, right? And so that way, if you delete pulley 1, it can see, well, that query is gone, so pulley 1 is gone, but pulley 2 is okay, that query still exists, so pulley 2 is also going to be okay, right? And so set external disambiguation just allows you to link that, right? And so if you look at the documentation for set external disambiguation, they talk about the niceties of that. Really all you have to do is, I like to do it by hand myself because I'm kind of old-fashioned. So I believe add flanges has an example. So all you have to do is add an unstable ID component that you're going to be iterating over, right? So that's your index, right? So pulley 1, pulley 2. So in this case, we're looping over each of our pulley definitions. So then we're, ID 1, 2, 3, 4. We're making it unstable. And then we're associating that with whatever user selection the user made to create that pulley, right? And typically that user selection will come from evaluate query because it's one-to-one with user selections, right? So the standard process is you evaluate the query, you iterate over each subquery that the, so each selection the user has. With that iteration, you have an index, you make an unstable ID, and then you disambiguate you tie the user selection to that ID, right? And then of course there's also for each entity, right, which just does the exact same thing, but inside a for loop, right? So this is also perfectly fine. Although I personally prefer just doing it by hand because for each entity, because it's a lambda function, sometimes you have to use boxes and things if you want to like manipulate a constant that's outside of it, or manipulate a variable that's outside of the loop. It's kind of hard. You also don't have easy access to an index inside for each entity, so it's a little bit harder to work with and manipulate. But that's just personal preference. They both work totally fine. Yeah, so that's that external disambiguation for each entity. So then the last topic we have here is tracking queries. So this is going to be start tracking and start tracking identities, right? And you might notice, right, let's see here, start tracking, yeah. So start tracking and start tracking identity, right? There's also these two functions here, make robust query and make robust queries batched, which I am going to talk about, but I'm lumping them in with tracking queries, right? And the reason why I'm doing so is if you go look at the source code for them, right, what you'll actually see if you look, where is it, here? Right, so if you actually look at the source code, you'll see, right, all this is doing is taking whatever query you pass in, right, evaluating it, and then Q-unioning that with a tracking query for said query, right, or an identity tracking query, right, and then make robust queries batch is just doing that inside an array, or inside a loop, right, so you have an array of each subquery rather than an individual one, right, and they're tracking from an operation, I guess, right, but you can see, right, this is just start tracking identity. And so make robust query is really for when you want a query or you might need to track that identity because it might change. And so it's nothing to, so it's, it's all fine, all kind of underneath that tracking query umbrella. So if you understand tracking queries and tracking, identity tracking queries, then there isn't really anything to talk about with make robust query specifically, right? But yeah, so what is tracking queries? What are they for, right? The core idea is it allows you to track queries through operations that would otherwise derive from a given entity, right? So what does that mean? That's very verbose. Well, so a classic example is if you track an edge of a sketch, right? So let's say we make a box or like a rectangle, right? And then we create a tracking query for one of those sketch edges, right? And then we extrude that box, right? Well, what is our tracking query now going to evaluate to, right? In other words, what has our sketch edge become, right? And the answer in this case is going to be the two edges on our final extrude, right? So when we make it three-dimensional, that tracking query is going to follow that extrude operation, and it is going to find those two sketch edges because those two edges on the final extrude, because those two final edges on the extrude depend on that underlying sketch edge that we defined, because that's what gives the box its shape, right? If you didn't have an underlying edge, then you wouldn't have those edges on the final box, right? There wouldn't be anything to create them in the first place, right? Even though the extrude itself is, using that sketch face. So that's pretty handy, and that can come in place, in a lot of cases where you're doing body operations or things like that, or you need, to follow a specific entity through an operation. So to give an example from my pulley feature, right? Here we're creating some bores, right? So like a circular pole or like a hex cutout inside a pulley, right? So you can run a shaft through it or whatever. So here, basically what I want to do is I want to add a chamfer on the outside edges of that pulley. I guess I can actually show it. I don't have to just look at code all day. Yeah, so here's what a bore does, right? So you can cut a bore, right? And you can also add an entrance chamfer, right? And so one key to this, right, is if you have a hex bore, for example, right, you can't just query for all of the edges on the bore itself or like on the pulley itself. Or well, actually, yeah, so this is actually kind of a quandary, right? Because you think about trying to query for like the entrance chamfer, right? You don't want to grab this outer edge because you don't want to chamfer that, right? You obviously just want to chamfer your bore, right? It's also kind of hard because once you've booleaned the bore, right, so like your hex tool or whatever, right, once you've cut the pulley with that, that tool is gone, right? So there's not actually an easy way to grab these edges on this pulley, right? And so the way we do that, right, is we use a tracking query, right? Now, when I coded this, I think I didn't think it through 100%, right? So I actually implemented a little silly. So the way I have it implemented is I actually look for the non-cap entities of the extrude. So these are the edges. So if you think about an extrude, right, it takes a face and it pushes and pulls it in two directions, right? So the faces is pushing and pulling are the cap entities, right? And then the non-cap entities are everything else, right? So the non-cap entities are going to be the edges, or the non-cap edges in this case are going to be the edges that run lengthwise if there are any, right? So in this case it would be these sets of edges because these edges are the cap entities, right? Oh, actually I do know why I did this. Okay. Yeah, so I can actually comment out the Boolean operation here. Let's do that. So this is what the tool looks like, right? And I make the tool arbitrary length because that's just a choice of mine. I think it's easier to just make the tool arbitrary length and like not have to worry about it rather than try to make it like the exact width, although I could easily do that. That's just a choice of mine, right? But one consequence of that, right? So the obvious thing to do would be to track the cap entities, right? So that would give you, the edges on this face and this face, right? Cut your Boolean, and then the tracking edges, the tracking query would evaluate to the edges on the pulley itself. But you can see from here, when you create an arbitrary length tool, right, these edges won't actually correspond to something on the pulley because they're out here, not, up here. So instead what I do is I track the inside edges, right? So the edges along that length. I do my Boolean, and if we have a chamfer, what I do is I grab all of the edges created by the Boolean, right? Because I can query for that using IDs, right? And then I just remove all the inside edges. So everything the Boolean created, it's not the inside edges, that's going to be your outer edges, and that works reasonably well, right? So a bit of some creative querying there, right, to achieve the result I want. That's how I'm able to identify, this outer chain of edges that I want. So then when you enter chamfer, it chamfers just these edges and not, the inner edges or anything else, right? But the key there is I'm using a tracking query to track these non-cap entities through the Boolean, right? So, after the Boolean, these edges are all going to inherit or going to depend on, the underlying edges from the extrude. And so therefore they're going to inherit their result. And so we can query for them and do it that way, right? And so a call out, right, you could use make robust query instead, right? That would also functionally work. But make robust query takes the original query and appends it with, your tracking query. It also tracks identity specifically, which is, I think that's more for like part IDs and things, although it can be for other operations. So if you're doing something where like, I'm not actually 100% firm on the difference between start tracking and start tracking identity. I believe start tracking identity is a little more strict. And so that might catch cases where like if you're doing like a Boolean, for example, with like a Boolean union or things, because that part gets merged with a different part. Although the Boolean preserves the identity of the first thing you select, or like it preserves like the properties off the first thing, but I believe all of the subparts that get merged into that body will like inherit that identity, because otherwise it would just disappear. So start tracking identity would probably follow through a Boolean, for example, although don't quote me on that because that might not be 100% accurate. But hopefully you get the idea, right? So, you have a query, you're going to do stuff that depends on that underlying query, and so you can follow it through. And so that way you can identify specific entities in your final result, which can be quite handy, right? And so one other call out I'll give, right, it's similar to queue dependency, but you set it up before the fact rather than doing it after, right? Queue dependency is also generally more, it tends to branch out more because it'll go in, because it can go in multiple directions. But this example here just kind of illustrates, how dependencies work. And so it's really just the opposite of that. Yeah, and then make robust queries are just trivial wrappers. The best case, sometimes you might conditionally modify a query, right? Maybe you're going to conditionally boolean something onto it, or conditionally do some operation that will, that could affect the identity, right? So maybe it makes sense to throw a make robust query on there, so that way you're able to track it. Even if you do that, end up doing that operation, you don't have to worry about, your identities getting all mixed up or remapped. But that's obviously a pretty niche scenario, right? Usually you're not doing that for everything. Although I do have an example of make robust query I can show in my code. So I use it here for these extrude features, right? So these extrude features here have to, so these features are trivial wrappers around the Onshape extrude feature, right? So we're actually taking all of the standard extrude UI, like starting offset and second end position and whatnot, and we're passing that into the actual Onshape STD extrude feature here using call sub feature and process status, right? But what consequence of that is, so one of the neat things we're doing is we're actually even going so far as to reuse the extrude manipulators from the Onshape standard extrude feature, so I don't have to program them all again myself, right? And the way I'm able to do that is, so the way manipulators work, right? When you call add manipulator, what happens is you associate, you add some manipulator data to an ID, right? And what Onshape does is it requires that ID that you pass into add manipulators to be the feature ID, because the feature ID is the only one it checks. It doesn't traverse the tree looking for manipulators you've added in random spots, right? It requires it to be the feature ID, that top level ID, right? And so in order to get the extrude features, the extrude IDs, I have to pass in my feature ID to the extrude function, right? And that does work, but the consequence of that is it can make it somewhat difficult to query for the results, because my standard technique of like queue created by ID plus like extrude won't work, because if I create like another body in the feature later on, then that query will also pick that up, which is not good, right? And so basically what I do is I call make robust query on the result, right? And so I don't actually really need the tracking part of this necessarily, but the evaluate query part is helpful, because that will evaluate into a set of transient IDs that are, at this point in time. And then so that won't change later on, right? Because, like this query, right, if I evaluate it after I've created the spacer bore, right, then, the context at that point will have the spacer bore in it. So, when you evaluate it, it will find that spacer bore in addition to, your actual spacers, right, your spacer bodies. But when you evaluate here, right, I haven't added the spacer bores to the context yet, so it's not going to find it, right? And so this query isn't going to get those spacer bodies if you evaluate afterwards, because the evaluate query has already run, and it's not going to, we're no longer querying generically for everything created by an ID, right? We're just querying for some specific results that we, previously had, if that makes sense. So that's a case where I use make robust query, really just for the evaluate query. But if you're doing like body corrupting things as well, offset faces doesn't do it, because that just like modifies an underlying face. But if you're doing things that might affect things, advanced things, perhaps make robust query could be helpful. But I certainly wouldn't slap it on everything, randomly. You should, but sometimes if you need to track something, because an identity is getting changed, it can be helpful for you. So that's all I have. Hopefully this was helpful. If you have more questions, feel free to leave them in the comments or tag me on the Onshape forums. And yeah, I hope this was helpful.